Okay, so as I just said, on today we're going to be starting a new topic which deals with energy. Okay, so we're moving away from universal gravitation. That was our topic for last week. This week, and of course next week, will be our energy focus. Okay, so the goal for today is to go over this PowerPoint that will be posted in Schoology. Go over a PDF file that has a few practice problems and practice concepts, and then I'm going to make the Schoology assignment available to you guys. It is the Schoology assignment is all multiple choice questions that you guys have to get done, and you should be good on those questions if you pay attention to the PowerPoint on today. Okay. See, some people are just now coming in. If you're just now coming in, um, guys, the attendance form is in the chat box, so please go ahead and get that filled out. Okay, let me go ahead and open up this PowerPoint so we can get started. Okay, so as I said today, the focus is energy. Okay, so uh, today we're going to be talking about gravitational potential energy, kinetic energy, and elastic potential energy, and we're going to kind of be explaining what all those terms mean and kind of differentiating between them. Okay, we're going to start with gravitational potential energy. Okay. Gravitational potential energy is the energy of an object's position due to gravity. And the reason why we call it potential energy is because it's stored energy. So any object above the ground or a ledge has potential energy. Uh, for example, guys, if I have a ball here in my hand, okay, so if you guys see me holding this ball, okay, um, just by me lifting this ball above the ground, I've given it potential energy. How do I know that I've given it potential energy? Well, because I release it and the ball falls, okay, it accelerates down to the ground. So in other words, the ball falls because it has the potential to become kinetic energy, which is the energy of motion. So by lifting this ball above the ground, I've given it gravitational potential energy because the moment I release it, it begins moving, it begins accelerating. And guys, it should be obvious that, the higher the ball is, and when I release it, by the time it comes to the ground, it's going to be moving even faster than compared to a lower point. So the higher I raise it, the more potential energy that I've given it. Okay. So that's what gravitational potential energy is. It's energy that an object has as a result of its height or its position. So in other words, if an object is on the ground, its potential energy is just zero. So guys, here's what you guys need to know. The equation for gravitational potential energy is an object's mass times 9.8 times height. So M stands for mass. G here stands for 9.8, the acceleration of gravity, and H stands for your height in meters. Okay, so we're going to see some examples of that in a moment. Okay, whenever we do those calculations. So let's move on to kinetic energy. So as I just said, kinetic energy is defined as the energy of motion. Okay, so since kinetic energy is defined as the energy of motion, an object that is at rest has no kinetic energy. Okay, so again, object at rest has no kinetic energy. Um, Kinetic energy increases with an object's speed. So that means if you're comparing two objects of the same mass and one of them is moving at a greater speed, then that object has a greater kinetic energy because again, kinetic energy is the energy of motion. Kinetic energy increases with mass. So let's say you're comparing two objects that are moving at the same speed and you want to compare their kinetic energy. Well, the one that has the bigger mass has the most kinetic energy. Okay. And the equation for kinetic energy is 1/2 times mass times an object velocity squared. So the velocity gets squared. Okay. Um, and just so you guys know, energy, the units for energy are in joules. So keep that in mind. The unit for energy are in joules. Okay. Before I move on to elastic potential energy, I want to share something with you guys, just so we understand what's going on here. Okay. So consider this person here on this skateboard. So we have this person here on this skateboard. Okay, and guys, as he goes up and down the ramp, I want you guys to notice how his kinetic energy and potential energy changes. Right now, ignore this part right here that says total energy. We're going to talk more about that in the future. For now, just look at his kinetic energy and potential energy. Okay, guys, notice how the higher he is, the more potential energy he has. Okay. Now, notice what happens when I release him. Notice how he gains kinetic energy as he falls downward. Okay. So I'm going to pause this here. Okay. Notice he has his greatest kinetic energy near the bottom here, and that makes sense, right? Because he's moving the fastest here. But as he goes to the top and slows down, he then gains potential energy, gravitational potential energy. So the higher he is, the more potential energy he has. So I'm going to play this in slow motion. So notice as he falls, as he picks up speed, he gains kinetic energy. But as he picks up height, he gains potential energy. So hopefully everybody see that. Okay. So here near the bottom, he has his most kinetic energy. And near the top, he has his most potential energy. Okay. So just so you guys understand that, so you can see the relationship between potential energy and kinetic energy whenever we have an object that's under the influence of gravity. Okay. And again, just so you guys notice, around this point right here, around the halfway point, kinetic energy and potential energy is about half and half. Okay. So here at the very top, he has basically full potential energy when he has highest height, and while he's at the bottom, he has his most kinetic energy. So I'm just playing this at normal speed so you guys can see what's happening to the skater in this case. One more thing I want you guys to see here. Notice that, notice what happens when I increase his mass. When I increase his mass, so he gets bigger, notice how the potential energy grows. So an object that has more mass has more potential energy. Okay, so just something to keep in mind. Okay. All right, so let me stop this and let me go back to the PowerPoint. Tanaya, there's the attendance form for you. Okay, guys, so let's finish up this PowerPoint. Okay. And by the way, we just saw this in what we just looked at, that, whenever the object is above the ground and it's at rest, it has all potential energy. As it falls, as it's halfway to the ground, it has both potential energy and kinetic energy. Okay, so they're about half and half. But as it falls, guys, just before it hits the ground, it comes to a stop. So it lost all of its potential energy and has gained full kinetic energy because it's moving as fast as at this point. Okay, so we're not concerning ourselves with this point right now when it hits the ground. Just we're looking at the point while it's in the air just before it hits the ground, it has its most kinetic energy. Okay. We're going to talk more about what happens as it hits the ground in the future. We're going to talk more about what happens to that energy. But for today, we're not focused on that. Okay. Now, the last thing that I want to talk about today on this PowerPoint is what is known as elastic potential energy. Okay. Now, guys, elastic potential energy comes from springs or any elastic object. Okay. So, for example, guys, guys, in my hand here, I have a pack of rubber bands. Okay. So a rubber band is an elastic object. Okay. So guys, elastic potential energy basically depends upon two things. It depends on basically the elasticity of the material, or sometimes what we call the spring constant, but it also depends on how much you stretch or compress the material. So for example, guys, if I take this rubber band and I stretch it, how do I know that by me stretching the rubber band, I've given it potential energy? What do y'all think? So guys, if I stretch the rubber band here, I've stored energy within the rubber band just by stretching it. Okay. And I know that because the moment I take the rubber band and the moment I release it, all of that potential energy becomes kinetic energy. So again, the moment I release the rubber band, all of that potential energy becomes kinetic energy. And I know that because when I release it, like assuming I was holding it and I released it and let it fly out that way. So the moment I release this, it's gonna fly off in that direction. So that stored energy, that potential energy, became kinetic energy. So everybody got that? So elastic potential energy, of course, depends on how much you stretch or compress an object that has elasticity. And this will be important in the future, this equation here for elastic potential energy, which is 1/2 times K times X squared. Okay, 1/2 times K times X squared. Um, where K stands for the spring constant. In other words, the stiffness or the elasticity of the material, whatever you're dealing with. And X stands for the distance stretched or compressed in meters. Okay, and that is it for our PowerPoint presentation. Okay, last thing that I want to do on today, I just want to look at a few things with you guys, just to be sure everybody's clear here. Okay. So looking at this PDF file here, okay, let us just work out a few of these problems together, just a few of them, just so everybody's clear on what's going on here. Okay. You know what? Let me open this in Kami so I can write on it, right on the screen. Give me just a second. Okay, guys, let us look at this first set of problems right here. So here, let us match these terms here with the correct description. Okay. So let's look at number 1, kinetic energy. So which one of these matches up with that? A, B, C, D, or E? Well, if you look here, it looks like C matches up with that because kinetic energy is the energy an object has because of its motion. Okay. Number 2, potential energy. Okay. And they're specifically talking about gravitational potential energy here. Energy because of an object's position above the ground due to gravity. Okay, so we want to match that with D. So gravitational potential energy. So it's stored energy. Okay. 3, energy. The term energy just means the ability to create forces or motion. So we're going to match that with B. Okay. 4, height. That's the vertical distance above the ground. So that's going to match that with E. Okay. And 5, joules. We just talked about that being the unit of energy. So we're going to match that with A. Okay. So let's keep going. Again, I'm just skipping around here, guys. I just want to be sure that you guys understand all these points so that whenever you guys are working out these multiple choice problems for your homework assignment, you guys are going to be pretty good on that. Okay. So what we want to label this here, we want to label this situation, are we dealing with potential energy or kinetic energy here? That's what we want to label. Okay. And again, on this worksheet, guys, they're specifically talking about gravitational potential energy. We're not going to focus that much on elastic potential energy for this particular worksheet. So number one, or this first one right here says, you have a car that is traveling at 45 miles per hour. Does it have potential energy or kinetic energy? So here, if it's traveling, it's in motion. We're dealing with kinetic energy. So I'm going to write kinetic energy there. Okay. A rock is on a ledge 5 meters high. So it's high, it's above the ground. So we're dealing with potential energy. Okay, so if it was on the ground, it would be 0 potential energy. A car is at rest at the top of a hill. So it's at rest, so it has no kinetic energy, but if it's at the top of the hill, it clearly has potential energy. I'm sorry, hold on. Excuse me, that's wrong. Let me erase this. So if a car is at rest, it has no kinetic energy, but if it's high on a hill, it has potential energy. Okay. A ball is thrown in the air and is still moving. This is interesting here. It's thrown in the air and it's still moving. That means it has both potential energy and kinetic energy. So it's thrown and it's still moving. Okay. A ball is rolling on the ground. It's rolling on the ground. So if it's on the ground, that means it has no potential energy, but it's in motion. So that means it has all kinetic energy. Okay. Any questions? All right, guys, we're almost done. Just a few more I want to discuss before I let you guys go. Let us look at this right here. It says circle the one with the more potential energy. So if you have a 25 kilogram mass or a 30 kilogram mass at the top of the hill, so they're both at the top of the hill. They're at the same height, but obviously the one that has the most mass has the most gravitational potential energy. Okay. So a car at the top of the hill or at the bottom of the hill, what has the most potential energy? Obviously the one at the top of the hill, because the higher the height, the more potential energy it has. So a plane on the ground or a plane in the air, well, it's obvious. If it's in the air, it has more potential energy. A full plane or an empty plane, both are flying, and we're assuming they're flying at the same speed. So obviously the full plane will have more potential energy because the full plane has more mass. Okay. Let's keep going. It says circle the one with the more kinetic energy. Okay. So a 25 kilogram mass or a 30 kilogram mass, both moving at 5 meters per second. So the 30 kilogram mass has more kinetic energy, okay, if they're moving at the same speed. So imagine so let's move on to this next one. You imagine you have 2 kilogram masses, one going at 75 meters per second and one going at 45 meters per second. Obviously, the one going at 75 meters per second has the most kinetic energy. So moving on, a car at rest or a car rolling down a hill, which one has the most kinetic energy? So the car rolling down the hill will have the more kinetic energy, okay, because it's moving. So a heavy bike or a light bike, obviously a heavy bike would have the most kinetic energy, assuming they're both moving. Okay. So last thing we're going to do, we're going to look at these last two. I want to show you guys how to do calculations. It says here we have a 4 kilogram rock and it's rolling with the speed of 10 meters per second. How to find its kinetic energy? Okay. So guys, remember the equation for kinetic energy is 1/2 times mass times velocity squared. So it's going to be, remember 1/2 is the same thing as 0.5. So 0.5 times 4, okay, which is the mass, and all of that times 10 squared. Okay. So guys, if you were to put that in your calculator, what you would get 200 joules for your kinetic energy. Okay, so 1/2, in other words, which is 0.5 times 4 times 10 squared. Okay, again, you get 200 joules of kinetic energy. Okay, so that's how you use the equation. Okay, now let us do one more, just so you guys will know how to do this. Calculate the potential energy of a 10-kilogram rock at the top of a 6-meter tall table. So remember the equation for potential energy. Sometimes you'll see it written like this: m times little g times height. In other words, the mass is 10 kilograms. Little g, guys, is always 9.8. It's just a constant, always 9.8. Times the height, which is 6 meters. Okay. So guys, if you put that in your calculator, you're going to get 588 joules of potential energy. So specifically gravitational potential energy. Okay. So that's how you use those equations. Any questions? Okay, that's all I'm going to do today. This video will be on YouTube if you guys will need to go back and look over it in order to be sure that you understand everything. The PowerPoint will also be in Schoology, as well as this PDF file that we just went over. But from this point on, the only thing you have to get done for the day is to get done with the assignment that I'm going to post, and you guys will be done for today.